Welcome back, everyone. Today I'll be doing trigonometric integrals, in other words, trig integrals, where there is a product of sine and cos, one having an even power and the next having an odd power. The one that has the odd power, I like to decompose so that I can see even plus 1. That's what I want, even plus 1. So having the number 3, decomposing it to have an even plus 1, I would have 2 plus 1. If I had the power to be 5, I will decompose it to have 4 plus 1. So this I will be decomposing because this is the one with the odd power. Now, I am also going to factor out the number 8. So I have the 8 on the outside. Integral of sine square 3x. And the next portion here, because I want to decompose it in this form, it will become cos square 3x times cos 3x. So the power is what we decomposed. So by right, there's a power 1 here. So applying the rule where when the bases are the same, so this is like the bases, you write the base ones and you add the power 2 plus 1, that gives us 3. So after decomposing it, my interest is now use trigonometry identity where cos square 3x plus sine square 3x is equal to 1. So the identity that we're used to is cos square x plus sine square x is equal to 1. So even if I have 3x, it's the same concept. So making cos square 3x being the subject, I carry this over. So what I'm left with is cos square 3x is equal to 1 minus sine square 3x. So having this, I can replace here. So I have the 8 integral sine square 3x and replace in my brackets to be 1 minus sine square 3x. So here I will have 1 minus sine square 3x. Then I have cos 3x dx. Now I will be expanding here. So sine square 3x times 1, sine square 3x times minus sine square 3x. So I have 8 integral sine square 3x times 1, that's sine square 3x. And sine square 3x times minus sine square 3x would be minus sine raised to the power 4. So we add the power 2 plus 2, and that gives me 4. A little bit of indices happening. Now, don't forget the cos 3x. So it means I need to multiply all of this that I've just multiplied, because I multiply sine square 3x times this bracket. But on the other side, I have cos 3x that can be multiplied here. So I also have cos 3x to be multiplied. So cos 3x times sine square 3x, then cos 3x times minus sine to the 4th 3x. So I have 8 integral sine square 3x and cos 3x. So I'll have sine square 3x cos 3x followed by cos 3x times minus sine to the fourth 3x, that's minus sine to the fourth 3x cos 3x. The last thing that is left to be done is to integrate each of these. And what I'm going to do is have the minus sign. I'm going to distribute the 8 and the integral. So this will be 8 and an integral sign, and I have my dx. I'm just putting it here. So let's integrate sine square 3x cos 3x. Let's remind you integration by recognition. The integral of sine to the n x cos x is equal to sine n plus 1 x over n plus 1 plus c. So if I have a number in front of x, then it will go in the denominator, so it times it by n plus 1 times a. So for this, by recognition, I will have 8 times sine, the power you would add 1, so you'd have 2 plus 1 is 3x, but in this case we have an a, so this would be 3 times 3. It's by recognition, this is the power n plus 1, and then if you have a, then we multiply the denominator by a. So a is 3, so that's why I have this 3, and I would add 1 to this, so it's 2 plus 1 to give me 3, and I'll also have the 3 here. So 3 3 is 9, so that means I have 8 sine cube 3x over 9. Now the next part have a minus sign. The power is 4, so I am going to have 8 sine, add 1 to the power, so 4 plus 1 is 5, 3x over 5 times 3. So you can clearly see that we have 4 plus 1 is 5. Anything you have as a power, you have it in the denominator, plus whatever is the coefficient of it, so you have it in the denominator, plus c. So this is 8 sine 5 to the 3x over 15 plus c. And that is our answer. Thanks for watching, guys. Don't forget to like and subscribe to my channel. And if you have any question, you can leave in the comments section below. Have a great day.